Okay, Trig class. Before we get to what I'm wanting to do today, I'm going to kind of run through what the next 2 weeks are going to look like because we really only have 2 weeks left. So today is April 27th. I'm going to go ahead and go through 3 sections of chapter 12. And the only reason I chose chapter 12 is because a couple of you guys had mentioned that matrices has shown up on the ACT quite a bit. And so I want to kind of go through that with you. And then also with matrices and solving systems of equations, there's a really cool trick on your calculator that can kind of help you solve systems by using your calculator. So I'm going to show you some cool tricks. Probably not until maybe Wednesday or Thursday. These 2 days we'll get into the calculator part. So I'll show you some of those tricks. So 12.1, 12.2. 12.1 will take 2 days to do. 12.2 might take us 3 days. So I have 3 days blocked out for that. So we'll see how that works out. And then 12.3 operations. This is the adding and subtracting, a lot of stuff that you see on the ACT. And then next Wednesday, Thursday, Friday is a final review. I'll give you guys a review packet, kind of like I do every semester to get ready for semester tests, and we'll go over those over 3 days. And there's like 50 questions on there, or 45 questions or something, so we'll do, like 15 each day. But all the high school teachers have kind of come to the general consensus that we're not going to do semester tests. So after that final review, you guys are done. For me. I do embed questions into that final review, so you'll still have to go through and fill those out, but you will not have a semester test. So yay, that's exciting. Now, I had my lesson plans ready to go until May 13th, but they told us to have you guys be done by May 8th because I think these 3 days, don't quote me on this, but I think these 3 days they're going to have you guys come into the school and like drop your books off and make sure you check your calculators in and that type of thing on those 3 days. So I don't know how they're going to do that, but that's just what I've been told. So your last day of having to watch or do anything for me is Friday, May 8th. Now, if you are a senior, which a few of you are in this class, your last day is Friday, May 1st. So I'll kind of put that in the video, just kind of a send off for the seniors. This is your last day. So you'll have these 5 days left, and then you'll be done. So let's jump right into section 12.1. These notes are on Google Classroom. If you need to run them off, there's only 3 sections of them, 12.1, 12.2, 12.3. So make sure you get those. But 12.1 is going to be a really easy section for you because it's all kind of review. So this is just solving systems of equations. Here's some examples of some really advanced systems. And we'll get to do a couple of these in tomorrow's video because I'm going to separate this over 2 sections or 2 videos. But, these ones solving these, this is 3 equations and 3 variables. This one has 4 variables. And this one has like quadratic, really this is the equation of a circle, x squared plus y squared equals 25. And this is the equation of a parabola. So this is like y equals x squared. So they're looking at 2 equations and 2 variables. So you may have more than one answer on these. We're going to solve one kind of like this one on the very back page. But they start us off with example 1 and just kind of figuring out what it means to solve systems. So they're going to start us with 2 systems of linear equations. This is x to the first power, y to the first power. And what I'm going to do to start with is I'm going to put him into slope-intercept form. I'm going to solve for y here, okay? So if I kick this 2x to the other side and we solve for y, we'll have negative y equals negative 2x plus 1, okay? And then if I continue and divide that negative over to the other side, I will have y equals positive 2x minus 1. That's what he will look like, okay? Now if I solve the second one, I'm going to kick the 3x to the other side, so I will have 2y equals negative 3x plus 12. And then if I divide by 2 on everything, y will be negative 3 halves. I'm going to leave him as a fraction. Don't ever convert him to a decimal because that's the slope. And then plus 6 is what he will be, okay? Now they want me to use a table to solve this, okay? You're not probably ever going to really use a table to solve these. You're going to use substitution or elimination, but we'll humor them and we'll solve using a table. So I'm going to do like a 3-column table. Here's my x's. I'm going to call this one y1. Okay, so this is my equation y1, and then here's my y2. Okay, So what we're trying to see is where the x's and y's cross each other, or where they have the same y coordinate, okay? So let's just plug in numbers for x. I'm going to start with -2, -1, 0, 1, 2, and hope that one of those comes out, okay? So if I plug -2 into this first equation, 2 times -2 minus 1, I think is -5, okay? If I'm just going to do all the y1s. So -1 times 2 is -2 minus 1, -3. 0 would be -1. 1 would be 1. 2 would be 3. Okay, that's what that column will look like. Now if I plug into y2, oh geez, -2 times -3 halves is going to be +3 plus 6, I think is 9. Yeah, I think so. Yeah. -1, this would be it would say, it would be +3 halves, which is 1.5, plus 6 is 7.5 or 7.5. If I plug 0 in, there we go, that's a nice number, 6. None of these are matching up, none of those y coordinates are matching up, crap. I hope I picked the right numbers. 1, plug 1 in, we get -1.5 plus 6, so 4.5. I'm going through this kind of fast, but we're just plugging numbers in, so whatever. If I plug 2 in, this would be -3 plus 6, which is 3. Yay, look at that. Okay, so what's happening here is that in the first equation, I have the coordinate 0.2, 3, and in the second equation, I have the 0.2, 3, right? So both of those are the same coordinate point, which means he's touching the same coordinate there, okay? So the solution to this system is going to be the 0.2, 3, because they have that in common for both equations, okay? So that's what it looks like when you're using a table. It's kind of ugly and kind of like cumbersome, so we don't usually do that. They want us to graph this one, and I don't know why they changed. I noticed this just a minute ago. I don't know why they changed this right here to a 4, so let's change it back to a 12. I'm going to fix that just because whatever. So we're going to use those same equations again. Y equals 2x minus 1, and y equals -3 halves x plus 6. Okay, so they want us to do this by graphing this time. Okay, so we're going to start with the first one. To graph him, I go down to -1, put a dot, and I go up 2 over 1, up 2 over 1, and etc. That's what he's going to look like. Okay. That's my first equation, okay? Then my second equation, I start with 6. Oh, shoot. 1, 2, 3, 4, 5, 6. So start up here at 6, put a dot, and then I'm going to go down 3, 1, 2, 3, and over 2. Ah, look at that. I should have known that because the point is 2, 3, right? We just solved that. 2, 3 is where they're going to cross each other, okay? So visually, that's what we're doing. In this section, we're trying to solve for the place where those two functions are crossing each other. Okay, that's what we're trying to do. Now, on the back side, we're going to be using substitution and elimination to do that, but you can also use a table, and you can also use a graph. You will end up sometimes getting weird answers. Most of the time, what's going to happen is you're going to have something that looks like this, where you have one solution, okay, and they're going to cross each other. Those two linear functions are just going to cross, okay? They call this a consistent system. I don't care what consistent or inconsistent or whatever. I just always make sure I remember that that means one solution, okay? So the whole consistent, inconsistent, I don't really care about that verbiage, I guess. Just know that when two lines are crossing each other like that, there's one solution, okay? Now, you might have a scenario where the two lines are parallel to each other, or the two equations are parallel, in which case you would have no solution. So we a lot of times will write it like this because they're not touching ever. Okay, and then sometimes you will have a scenario where you have both equations that are the same. They're exactly the same equation and they're living on top of each other, in which case they have infinitely many solutions. Okay, they're touching at infinitely many points. Okay, and a scenario when you might have that happen, I'll just give you an example. Let's say I have x plus y equals 1, and I have 2x plus 2y equals 2. Well, really, the second equation is the same as the first one. I've just multiplied it by 2, which I could then turn around and divide it by 2, and I would get back to the original. So that's going to be two equations that are going to live on top of each other. They're going to have infinitely many solutions. Okay, So let's go to the back side. Let's talk about substitution and all that good stuff. Number systems, there's a little box up here that says there are exactly 3 possibilities when you have linear equations. And those are the ones that we just got done solving. So only 2 variables, an x and a y, both of them to the first power. Not anything weird and crazy like this yet. So if you have 2 linear functions, there are only 3 possibilities. Either you're going to have no solutions, 1 solution, or infinitely many solutions. Okay, just like we just talked about. Okay, so this one, example 3, they want us to solve the systems of equations below by substituting. Okay, so we are going to use substitution, and what we have to do is we have to solve one of the equations for a variable. Okay, so I can either solve for this x, this y, this 2, or this y. Or excuse me, this x and this y. The easiest one that I want to solve for is probably going to be this y right here because he has no number in front of him. Okay, so we can rearrange him pretty easily. Okay, so what I'm going to do is I'm going to kick this 3x to the other side, which will still give me negative y, but then he'll be equal to negative 3x plus 12, and then I can divide by that negative, so y will be positive 3x minus 12. Okay, now I can substitute him in. So I can take this guy and I can plug him in, and I want to plug him into the bottom equation for y, because I solved the top one. Okay, so 2x plus 3 times 3x minus 12 equals 2. All right, and then when I get to this point, I'm going to distribute that through. So 2x plus 9x minus 36 equals 2. Okay, I'm trying to go kind of fast through this because I know this is a lot of review, but you know, whatever. 2x plus 9x is going to be 11x, and if I add the 36 to the other side, I will have, did I do all that right? Yeah. Yeah, okay. If I add 36 to the other side, I'll have equals 38, and that is not a nice answer. Yuck. If I divide by 11, it's going to be like 3 point something. Let's see, what do we end up getting? 38 divided by 11. Ugh. 3.45-ish. Something of that nature. Okay. Now I want to solve for y, so I'm going to plug him back in. Plug the x back in there. So y equals 3 times 3.45 minus 12. So I'm going to take what's already in my calculator. I'm going to multiply him by 3. And I'm going to subtract 12. And the y coordinate will be negative 1.64-ish. Yuck, that was a yucky one. Okay, so I'm going to write that as an ordered pair, which is 3.45, comma, negative 1.64. Okay, and why do I care about this point? Like what happens there? That's where those 2 lines are going to cross each other. Okay, solving the system of equations below by elimination. So I want to eliminate a variable. So adding the x's together, adding the y's together, one of the variables has to eliminate. If I try to add them together right now, nothing will eliminate. But what I can do is, let's pick on the y's. Let's do that. Let's pick on the y's, and negative 3y, if this is a positive 3y, he will eliminate. So we're going to multiply the bottom one by 3. All right, I'm going to leave the top one alone. I'll leave him x minus 3y equals 4. Okay, but the bottom equation I'm going to distribute the 3 through. So 6x plus 3y equals 3. Okay, I'm going to end up with something really ugly again. No, I'm not. The y's cancel out. X plus 6x is 7x and equals 7. Okay, and then if I divide by 7, the x will be equal to 1. Okay, now plugging them back in, I can plug them in here or here. It doesn't really matter. Let's just plug him into, I don't know. Let's plug him into the top one. Sure. 1 minus 3y. I'll plug that 1 in. Equals 4. All right, so if I subtract the 1 over to the other side, I'll have negative 3y equals 3. And if I divide by negative 3, y equals negative 1. So my point for my answer is 1 comma negative 1. That is where those 2 lines would cross each other if I graph them. Okay? All right, 2 left, but we'll do these 2 and then we'll stop. So we're going to end up with some funky business happening in example 5 and example 6. So we'll see what that looks like. They want us to use elimination on this one. So let's see what happens here. Let's take this top equation, and let's say I want to cancel the x's out. So if this is 4 down here, I want this to be 4 up here also, and I'm going to multiply him by -2 because he has to be a -4 in order to cancel. So the top equation is going to look like -4x plus 6y equals -10. The bottom is going to be 4x minus 6y equals 1. Okay? All right, so my x's canceled out, but so did my y's. So I have my equal sign here, and then I have nothing left on this side, so we just put a 0. Okay? -10 plus 1 will give me -9. So this is a weird answer, a weird solution that I get, because we look at 0 equals 9 and we say, when does 0 equal 9? Well, 0 is never equal to 9. That doesn't happen, right? So this is going to be a scenario where I have no solutions because 0 is never equal to -9. These two guys are going to be parallel to each other, okay? So I'm going to put parallel lines. Okay. All right, and then let's do this last one. We're going to end up with another weird thing happening here. So they want us to do elimination again. So here we have this. Let's see, which variable do we want to eliminate? Oh, we got fuzziness going on. There we go. Okay. Let's go ahead and eliminate the x's. Okay, so I have 2 and -3. I'm going to have to multiply both equations here. Let's multiply the top by 3 and the bottom by 2. So then I get 6's for both of them, and the bottom one will be a -6. So if I do that, 3 distributed through will give me 6x minus 12y equals 18. Bottom one will give me -6x plus 12y equals -18. Okay, so that's what I'll have there. All right, so 6x, 12y, oh geez, we got all sorts of stuff that's canceling out. Okay, so here's my equal sign. On this side I have nothing left, and on this side I have nothing left. So I have 0 and 0. Okay, but when does 0 equal 0? 0 is never equal to -9, but 0 is always equal to itself. Check. So this means that there are infinitely many solutions because 0 is always equal to 0. So in this case, these two functions are going to be the exact same function. They're just going to be the same line on top of each other. So same line where we get infinitely many solutions. So this is kind of what it looks like, or what it boils down to when you end up with funky answers or no solutions and infinitely many solutions. Okay, you'll end up with something equals itself, or you'll end up with something equals something that's not itself. And that's kind of what he will look like. Okay, so in the next video, we'll do these 3 problems, which take a little bit longer, and then we'll be scooting right along.